Welcome to the Slop Temple. We pray this video helps.
You begin by securing practical prerequisites, linear algebra and complex arithmetic, plus basic probability. Once you have Python and NumPy, install a quantum SDK like Qiskit or Cirq and run the included tutorials to see qubits in action. Make sure to play with simple gates and measurements so you feel the mechanics. This immediate hands-on step grounds abstract math. It forces intuition about superposition and measurement probabilities rather than only reading theory. Once done with basics, deepen your understanding by combining theory with code. Map block sphere intuition to gate matrices and implement entanglement experiments to see non-local correlations. Practice building simple algorithms like Deutsch-Jasa, Grover, and variational circuits. This shows why algorithm design leverages interference. Make sure to use simulators first to debug, then run on noisy hardware to learn error behaviors. Reading calibration and noise profiles teaches you practical constraints and how to design noise resilient. You finalize your path by selecting a specialization: algorithm design, hardware engineering, error correction, or quantum machine learning, and committing to projects that produce reproducible results. Once you reproduce seminal experiments, contribute code or write notes that clarify assumptions. If progress stalls, isolate the problem. Run the circuit in a noiseless simulator, then add noise models and compare. Check calibration data and gate fidelities. This troubleshooting loop reveals whether issues are conceptual, implementation bugs, or hardware noise.
Thanks for watching. Consider subscribing if we helped you.